Hello and welcome to HydrFLASH video tutorial. My name is Dr. Ramin Musavi, and in this video I'm going to outline the main HydrFLASH calculation features and modules, and we are going through all these modules available in HydrFLASH and how it can be used for PVT modeling calculations. Um, so when you learned how to create fluids, how to characterize them for wax or asphaltene calculations, and how to tune them, you can use those fluids to perform any calculations, either flash calculations, saturation properties calculations, hydrate prediction calculations, or any other calculations. The only exception for flash calculations is the fluids that you use for asphaltene characterization. I will explain that in the asphaltene calculation shortly. So apart from asphaltene calculations, you can perform any flash calculations using HydrFLASH when you have introduced fluid into any database you have saved, for example, natural gas, an aqueous solution, or a characterized fluid which has been tuned with experimental WDT data or saturation or PVT lab test. Flash calculations is basically calculating the phase equilibria of a system at constant conditions. And by conditions, I mean 5 different parameters: the temperature of the system, the pressure of the system, the total density of the system. Just be careful, we're talking about the total density of the system, not the density of gas, water, or oil. The total density of the system. So a system can be in different phases, but what we need here is a total density, the total enthalpy and the total entropy of the system. So what you will see in oil and industry a lot is a flash drum, is a vertical two-phase drum. In this drum, a fluid, an oil or condensate flew through this pipeline and then passes a throttling valve. The pressure drops, and then the gas, the two-phase fluid, enters this flash drum, and then the vapor goes from the top of the vessel, and the liquid um, is extracted from the bottom of the vessel. So in this vessel, you have two phases in equilibrium, and or maybe in a separator, in a wellhead, you have three phases in equilibrium: gas, water, and oil. Just this vertical vessel is just was simpler for illustration, so it doesn't really matter how many phases you have in the system. um, HydrFLASH can predict 2 and 3 phase flashes using the CPA equation of the state. But the important thing to remember is that these parameters. So when the composition of the feed is known, you have introduced the composition, you have created this fluid, you have tuned it, you have characterized it, so you know the composition of the feed. And if you have any two data from all these 5 parameters, then you can predict the phase compositions and fluid phase properties of all phases in equilibrium. For example, in a PT flash calculations, you know the temperature and pressure of the system as well as the composition. And then when you have these 3 data, if you have a two-phase system, you will have the gas, oil, and water composition. And also, you can predict other properties of these phases, like the density of these phases, the enthalpy of these phases, entropy of these phases, CP, CV, etc. Or for a case that you know the temperature and density, total density of the system, then you can predict the pressure and the phase composition and fluid phase properties. Or when you know the pressure and enthalpy, you can predict temperature and density and entropy of all the phases and the composition of the phases. So there are different combinations. You can make different combinations of these parameters. T, PT, or P, density, or pressure, enthalpy, entropy, density, or density, temperature. In HydrFLASH, we have introduced 6 different flash calculations. Most used flash calculations, which are PT flash, which is a flash calculations at constant temperature and pressure. VT flash, or the flash at constant temperature and density. TH flash, which is at constant temperature and enthalpy. And pH flash and PS flash, which is pressure and entropy calculations. So in all these calculations, if you know 2 parameters as well as the feed composition, you can predict the phase, you can predict how many phases you have at those conditions. Either it's a single phase, it's a 2 phase, or it's a 3 phase. Also, it will give you the phase composition and the phase properties, like the density, enthalpy, CP, CV, second thermodynamic derivatives, anything. So basically, in flash calculations, you are modeling the phase equilibria of a system by knowing the total composition of the system and the total parameters governing that system. It's either temperature, pressure, it's a density, it's enthalpy, which parameters are known. And then when 2 parameters are known, then the other parameters can be predicted. But the important thing is that you need to remember which fluid you are using. If you're using an uncharacterized fluid, for example, a natural gas, a natural gas doesn't need to be characterized. Or when you are using an untuned oil, live oil, then the properties you predict here, because the model has not been tuned with the experimental data, may be not reliable. But if you tune the model using appropriate experimental data, then the predictions are very well reliable. So this is a summary of total idea of flash calculations and how we do it in HydrFLASH. So again, as a summary, for performing flash calculations, you need to define fluid, then choose which calculations you want to do, and then it will be the result will be shown, which and shortly I will show you where you can find different information in flash calculations. Okay, so to perform the flash calculations, as the name of the calculation says, you need to navigate to the calculation tab here. So you see different sections. The one section is flash calculations, which includes all the modules regarding the flash calculations and the hydric calculation or asphaltene and etc. So you can see that we have 6 flash calculation modules here: PT flash, pressure, temperature, pressure enthalpy, temperature enthalpy, density temperature, pressure entropy, and temperature entropy. So to activate the parameters and the feature for each calculation, you just need to click on it. So when you click on it, the features and the options related to this calculation is activated here. You see PT flash. So if you want to perform a TH flash, just need to click on this button. Then the TH flash calculation features will appear here. If you want to change any units, for example, go to the SI units or metric units, or if you want to change any settings here, that you just need to navigate to the data, and parameters, if you just need to navigate to the parameters. Okay, so let's start with HydrFLASH here. Okay, so you can see several features here. The first one is the drop-down menu here. The first drop-down menu is for activating a fluid. So for which fluid you want to perform a HydrFLASH, or what is the feed of this calculation. If you remember from the presentation, I was talking about the feed, the composition of the feed entering a flash drum, a 3 or 2-phase flash drum must be known. So here you need to just select which composition you are feeding into a flash drum and you want to perform a HydrFLASH for. So for example, I choose here natural gas, and then it's very easy. Just if your units of temperature is Fahrenheit and bar or PSA, and then the other one is the display multiple flashes in the same grid. I will talk about this a little bit later. So that's fine. So you change the units, and then you ask, okay, so for example, standard conditions, atmosphere, 1 bar. So 60 Fahrenheit and 1 atmosphere, which is the standard condition for this natural gas. And then I simply press run, and it shows me the results. As you can see, natural gas, this gas is vapor at the standard conditions. Okay. So let's feed another fluid to this flash calculation. So this reservoir fluid at the standard conditions, it's a live oil sample. If I go back to the fluid management tab and I want to see what is this composition, okay, I just press edit, and as you can see, it's a live oil sample, and the PVT, it's also say it's a live oil. So because I have saved this information before, so I remember, okay, it was a live oil sample, and from the composition I can tell that this is a live oil sample. It has 6 mole% heavy oil fraction, so, and also 40% of methane, so it's live oil. So I just wanted to check the composition, so I close this one. I go back to the calculation tab. Although the features here is activated, if you go to any other tabs, these panel features are still available. But anyhow, because we want to talk about the flash calculation modules, let's be on this tab. Okay, so I'm feeding a live oil sample to this flash calculations. My preferred temperature and pressure units are Fahrenheit and atmosphere, and at 60 degrees and 1 bar, and then I just press run. Now you can see that at the standard conditions, let me expand this window. Okay, at the standard conditions, I have 2 phases. I have a vapor phase and I have a liquid hydrocarbon phase. So HydrFLASH predicted at these conditions, this composition is separated into 2 fluids, vapor and liquid hydrocarbon. And this liquid phase is for the aqueous phase. So because we don't have water in this feed, so the water phase does not form. So you can see the composition of each phase. As you can see, the methane concentration in the vapor phase is very high, and it is low in liquid hydrocarbon, as explains. So it's basically a separator at atmospheric conditions. So it flashes the vapor, release the vapor, and the dead oil sample now is this the composition of the dead oil sample. Okay. So the third part, so this is the composition of each phase I was talking about. You can see the composition. And this part is for the fluid phase properties I was talking about. So as you can see, for vapor and liquid hydrocarbon phase, you have these data. You have the molecular weight of them, the molar phase fractions. What does it mean? The molar phase fractions means how much the fraction of the total feed of the total system is vapor phase and how much is the molar fraction of the liquid phase. So these data is telling me that 62 mole percent of the system is vapor and 37 mole percent of the system is liquid. The weight phase fraction, it's the same thing. It tells me 11% of the system, of 11% of the mass of the system, the weight of the system is vapor, and 88% is liquid. Because liquid is heavier, so you expect that the more weight percent of the system will be liquid phase. Or volume phase fraction, because vapor occupies more volume, so 99 volume percent of the system is vapor and only 0.8% or roughly 1% of the system, of the volume of the system is liquid. So it also tells me that 99% of the volume of total volume of that flash drum is actually vapor and only 1% of that volume is liquid. But that 1% is 88% of the weight percent of the total system. This is the compressivity factor of this liquid. As you see, compressivity factor also known as the ideal behavior deviation factor. So it means that this is also denotes by Z letter. So if this value is closer to 1, that means it's closer to the ideal behavior, ideal gas behavior. So as you can see, the vapor phase is 99, so it's close to 1, and this is the vapor, and the Z factor of the liquid phase is 0.1. The density of each phase, as you can see, the density of the liquid phase is much higher than the vapor, sorry. The molar volume, which is the opposite of the density, is the volume of each phase per mole of each phase. Is this value for vapor and liquid phase. The entropy of these two phases, the Cp, Cv, sound velocity in these two fluids, Joule-Thomson coefficient in these two fluids, and viscosity of these fluids. And also the thermoconductivity of these fluids. And in the last section, you have the model and the settings you have used for this calculation. So the CO2 alpha function is Matthias-Koopman, the equation of state is CPA, and the non-associating part of the CPA is SRK, and the association scheme is solvation motive, although we don't have water in the system, so that's fine. In this column, you will see the properties of the feed of the total system. So if you want to know what is the enthalpy of a multi-phase system, you need to perform a flash calculations and read this part. Okay, so the total enthalpy of the system is minus 281, while the enthalpy of the vapor phase is minus 19 and the enthalpy of the liquid phase is minus 338. So this is the value that is important for us in pH, TH, or TS and PS flash calculations. The total enthalpy and the total entropy and the total density. As you can see, the total density of of the fluid of the system is higher than the density of the vapor and is much lower than the density of the liquid, because it's the total density of the system is somewhere in between. So for VT flash, we need this density, not these densities. Okay. So you see this data here, and it's a grid based. You can select them, or you can just press Ctrl A, selects everything, or you can just select a part you want and then right click on it, press copy. It copies to the clipboard, and you can paste it in an Excel file or a text file, or you can convert the units, everything, Fahrenheit, atmosphere, everything. You can convert it. If you change your mind, you can just change this one and then close it. And you can export this data to an Excel file. You just need to specify a name, for example, PT Flash, and then specify a folder. So a name for an Excel file and a path for that Excel file, and then press save. Now it is being exported. So so as you can see, this Excel file is here. So you have this data. Also, you can save these results on a database by simply clicking on this button. So when you save these results on a database, everything that is being shown here will be saved on a database, and you can come back later and then see, okay, what was the result of the calculation I performed 2 days ago, 3 days ago, 3 months ago. So you can store all the calculation results in a database as well. So if you remember from the database video tutorial, it's we can save two things, two type of data on HydrFLASH databases. First, the compositions, the fluid, and the second, the calculation results. So let me save this database on a database. You choose a name. Tell me first calculation results, and then press save. It is now saved. And if I go to database management tab, and press this button, results list, you see, the results I have saved on this active database is shown. I can double click on it, shows me the composition, and it gives me the data. So let me close everything. Now imagine we are in a time machine and it is 6 months later. So I want to see what I have done 6 months ago. So I have this, okay, HydrFLASH database. I remember I have saved some results in this. So let me activate it. Let's go to the results list. Okay, this is the first calculation results. This is the calculation results I have saved. And then I double click on it and the result will be shown. I didn't perform any calculation or I just reload the calculation results. So this is one of the advantages of using databases in HydrFLASH, and in particular HydrFLASH software itself, because you can calculate many data, many calculation results in a single database. So you can have 50, 60, 100 fluids saved on a database, and more than 200 calculation results on a single file. So imagine if you want to create like any input file for different softwares, then if you perform any calculation, you save it on a text file, on an Excel file. So you will end up with having so many files, and organizing these so many files are so different. But here in HydrFLASH, you see the date. It's very organized. You see the type, and you see your name that you use for to save that database. Also, you can make a backup. Instead of making a backup for 100 files, you just make a backup for one file, which is your database. Okay. Let's go back to the calculations and select other calculations. So for example, you see, when I calculated this fluid, these are the enthalpy and entropy of the total of the system. So let's back calculate this. So if I go to VT_FLASH and just try to back calculate this. So what does it mean is that I put the temperature at 60 and the total density of the system was 67.638, and so I want to know what will be the phase equilibria at these conditions. The total density of the system is 67 at 60 Fahrenheit. It must give me exactly the same phase equilibria. So let's run it. As you can see, it gives me exactly the same data, and the pressure it gives me, okay, at this temperature, if your total density of the system is this, your pressure will be 1 atmosphere. And this is the composition and fluid phase properties at these conditions. In particular, this calculation is very useful to know that, okay, if you want to load a cylinder, you know the temperature. The temperature is the temperature of the lab, 60 Fahrenheit. And then you know how much, you know, for example, that you want to inject exactly 300 grams of ibutane or a gas to a cylinder. Okay, so let's imagine you want to inject 100 grams exactly of a gas to a cylinder. So weighting a gas is very difficult. So what you can do in a lab is that you know you have the molecular weight of that gas or a reservoir fluid, 89. So 100 divided by this value is the density. 100 is the number of moles. You know the volume of the cylinder, so the number of moles divided by the volume of the cylinder will be the density. So you know the density and you know the temperature. You just need to know how much must be the pressure. So you load the cylinder until you reach a certain pressure, the pressure that the VT_FLASH is telling you. It's one of many advantages of using VT_FLASH. Although I'm just in these videos, I'm presenting simple calculations. In our online courses, we investigate more complicated and more practical examples, and we use HydrFLASH to model those data. So the purpose of these videos is only to help users get along with HydrFLASH better, and they learn how to use different features. Okay, so this is the VT_FLASH. Let's do the same thing with pH_FLASH. Okay, so the total enthalpy of the system was minus, let me just copy this value. Okay, so the total enthalpy, okay, I don't know, for some reason it doesn't paste. Okay, minus 208 minus, yeah, 1. Okay, copy. Okay, now I paste it. So at the end of the total enthalpy of the system is minus 281, and the pressure of the system is 1 atmosphere. It must give me exactly the 60 Fahrenheit temperature, because I'm giving two parameters. So with this system, 60 degrees, 1 bar, and these are the density, enthalpy, and entropy. So I'm giving the enthalpy and pressure, so it must give me it must predict the temperature, entropy, and density. So let's do that. And as you can see, it predicts the temperature of the system. So I kind of back calculated it. And these are the phase compositions at these conditions, temperature, entropy, and these are the fluid phase properties. The same thing for example, TS flash calculations. Let's copy the entropy, the total entropy of the system, and the temperature of the system, which is 60 degrees, and then pressing calculation. The pressure is almost 1 and 60 degrees, and this is the entropy. If you want to let me save all these data, so for example, I call this TS flash. I save this as pH flash. Save. Okay. And I save this as VT flash. Save. Okay. Now I want to close everything. Close this one and I close this one. Exactly. We get on a time machine. 6 months later, I come back here, go to a database management tab, and I just want to review what I have done 6 months ago. So I go to the results list, and there you go. I have all the calculations here. I have VT flash. This is the date and the time I have saved this data. And I want to review what was the PS flash calculations. So I just double click on it and it will load. Okay. So basically, each one of these flash calculators has different applications and practical. We will explain we will use these calculation modules in our online courses using practical examples, practical engineering examples. But as I said, this video tutorial only for tutorial, and I want to just show you how you can use HydrFLASH features. Again, if you want to change the engine, the equation of states, and perform, for example, flash calculations with different, let me change it to 60 degrees again, different equation of states, you can just change the equation of state, VPT, Peng-Robinson, anything. But again, if it's not relevant, the default, we recommend that you use the CPA equation of state, which is the default equation of state for this fluid. Okay. Right. And the other option is to display multiple flashes in the same grid. So when you click on this, it shows, so let me change the pressure. So let me first run this calculation and show what is this. So when you click on this button, it shows all the calculations in a same row. This is very helpful if you want to change, if you want to see the changes of any parameters, if the composition, any fraction concentration, or fluid phase properties, say for example CP of the vapor gas, of the vapor phase, sorry, over changes in the temperature or pressure. So for example, this is, let me close this one. If I want to see what would be the changes in the enthalpy of the liquid phase by increasing the pressure of the system. So let me enter 5 pressures. So 1, 5, 10, 15, and 30. Okay, so I have entered multiple conditions and I have ticked display multiple flashes in the same grid. Then I press run. So as you can see, all these data are same in the same grid. Then if I navigate to the enthalpy, as you can see, the enthalpy of the liquid phase is changing with pressure. Or for example, the compressivity factor or CP or density or any other important parameters, you can watch them and you can see what will be the changes. So this is the one advantage of using this optional feature here. So, but if you don't want to see everything in the same grid, you just untick this and you have 5 flash calculations here. When you press run, multiple tabs, now see 5 tabs are now open and you see the calculation results in different tabs. But if you click on this and you press run, you will see everything on the same grid and you can compare them. This applies for other calculation module or other flash calculation modules as well. So as long as you press this one and enter multiple conditions, you can compare the results and you can see the results in the same grid.